Hey there, welcome to this video of Take It Easy Chemistry. In this video we will have a general introduction to our newest chapter, that is haloalkanes and haloarenes. Okay, so let's start with the definitions of haloalkanes. Haloalkanes, also known as alkyl halides, are your typical organic compounds which are obtained by replacement of one or more hydrogen atoms of aliphatic hydrocarbons by halogen atoms. So to obtain haloalkanes or alkyl halides, we are going to replace hydrogen atoms of aliphatic hydrocarbons. Now aliphatic hydrocarbons, as you would have already known, these are your open chain structures. Open chain structures. This you would have already studied it in your earlier classes, but we are just having a quick recap to our basics. So bear with me in this video. Haloalkanes are also called as alkyl halides. Now what are alkyl halides? Haloalkanes are also called as alkyl halides. Let's see what these alkyl halides are, or what these haloalkanes are with an example. Suppose I have an alkane. Let's say I have an alkane, and any alkane for that matter. Let's say I have a methane. Let's say this is your methane. This is your simplest alkane, methane. Okay, this is your methane, and suppose what I am going to do is I am going to remove a hydrogen atom, and let's say any hydrogen atom. Let's say I'm going to remove this hydrogen atom from this structure. I'm going to remove this hydrogen atom. I'm going to break this bond and remove this hydrogen atom completely from the structure. So what will I get? I will get something like this. It will look something like this. Nothing will be here, and your hydrogen and your other hydrogen atoms will be at their initial position. And so this is your structure of alkane with one missing hydrogen atom. And what will we call this structure? We call this structure as your alkyl group. So when you have an alkane and you remove a hydrogen atom, we call it alkyl. And in this case, this is your methyl. This was your methane before, so it will be converted into methyl, methyl, methyl group. Now this is the main idea what we are going to study here. This is your methyl group, or this is your alkyl group. Now to this alkyl group I am going to add a halogen atom X. Now this is your halogen atom X, where X could be anything. It could be your fluorine, or it could be your chlorine, or it could be your bromine, or it could be your iodine. It could be your any typical halogen atom. So if I add this halogen atom to this alkyl group, I will get something like this. It will look something like this. This will be your structure of your, if I add your halogen atom to this alkyl group, and this structure what we just got here will be called as your alkyl halide, or it is also called as your haloalkane, because this is your alkane group and this is your halogen group. So haloalkane or your alkyl halide, and in this case it will be your methyl halide. This was your basic definition of your haloalkane, and that is why we also call it as alkyl halide, because this was your alkane. We removed the hydrogen atom, it was converted into your alkyl group, and when we add a halogen atom to this alkyl group, it becomes your alkyl halide. That was your basic definition of haloalkanes. Now another thing to note in this definition is the fact that this halogen atom is attached to a carbon atom. In this alkyl halide, this halogen atom is attached to a carbon atom. Now what is the hybridization of this particular carbon atom? What is it? What is the hybridization? Now, if we talk about the hybridization of this carbon atom, we will say that this carbon atom is sp3 hybridized. Hybridization is a concept which we have already discussed in our earlier classes, but let's just have a quick recap. When we say a carbon is sp3 hybridized, we say it because it is attached to 4 particular atoms. In this case, you can say it is attached to 3 hydrogen atoms and a halogen atom. That is why we are saying it to be sp3 hybridized. If it is attached to two particular atoms, we say then it is sp hybridized. If it is attached to 3, we say it is sp2 hybridized, and if it is attached to 4 halogen or 4 any particular atom, we will say that it will be sp3 hybridized. So as you can see, this carbon is attached to 4 hydrogen atoms and 1 halogen atom. We can say that this is your sp3 hybridized carbon atom. Moving on to our next definition, we have your haloarenes. These haloarenes are also called as your aryl halides. The concept is same here. When we say that in your alkane we are removing a hydrogen atom, it was alkyl group. Similarly, if you have an arene, and if you are removing a hydrogen atom, we will say then it is aryl group. And if you are adding a halogen atom, we will say that it will be your aryl halide. The definition is quite same. The only difference is the fact that in terms of haloarenes, we are talking about aromatic hydrocarbons. Now, aromatic hydrocarbons are your closed chain structures. Your benzene is the best example. Your benzene ring is your aromatic hydrocarbon. So this is your benzene ring, and this is your halogen atom attached to this benzene ring. Now this is what you call as your haloarene. The basic concept here is the fact that we are going to remove a hydrogen atom and we are going to replace it with a halogen atom. So let's say I have this benzene ring here with a hydrogen atom H, and what I'm going to do is I am going to remove this hydrogen atom from the structure and I am going to replace it with a halogen atom X, where X could be anything from fluorine, chlorine, bromine, or iodine, and this is your basic haloarene. One thing to note here again is the fact that this carbon atom, which is attached to halogen atom, to which halogen atom is attached, is sp2 hybridized, because this carbon atom is attached to three particular atoms, that is 1 halogen atom and 2 different carbon atoms. That is why we say that this is sp2 hybridized carbon atom. This was about your basic definition of haloarenes and haloalkanes, and in the next class we will have a basic introduction to our classification of these haloalkanes and haloarenes. So join me on this journey of haloalkanes and haloarenes, and let's see you in next class. Have a great day ahead.